Good evening. Atif, any doubt?
No.
So let's discuss question paper. The first question is, a simple harmonic motion is described by A is equals to minus 16 times x. According to acceleration in SHM, it would be A is equals to minus of omega square x. So just compare this expression to this part. So on comparing, you will get omega square is equals to 16. So omega will be root under 16, that is 4. And since in this part, we have to calculate time period. So omega is equals to 2 pi divided by t. So t will be equals to pi by 2 seconds. So this will be your first answer. Riba, is it clear?
Yes.
Second one, find displacement of simple harmonic oscillator at which its potential energy is half of maximum energy of oscillator. According to expression of potential energy, it will be half m omega square y square. And maximum energy will be equals to total energy, which is equals to half m omega square a square. So according to the question, potential energy is half of maximum energy. So we'll say U is equals to half of E. Just substitute their values. Half m omega square y square is equals to half, and total energy is half m omega square a square. Half m omega square, half m square will cancel out. So you're left with y square is equals to a square by 2. So y will be equals to plus minus a by root 2. So at this displacement, potential energy will be half of total energy. Atif, is it clear?
Yes, sir.
Third one, the frequency of two tuning fork A and B are, so F1 we have 250 Hertz and F2 is 255 Hertz. We have to calculate beats frequency. So beats frequency is nothing but difference of frequency of two waves. So you may write beats frequency is equals to F2 minus F1. So on subtracting 255 and 250, you will get 5 beats per second. But in this question, we have to calculate number of beats produced in 5 seconds. So you may write beats frequency is equals to number of beats produced divided by time taken. So beats frequency we have 5. Number of beats we have to calculate divided by time taken is 5. So on solving, you'll get number of beats produced will be 25 in time interval of 5 seconds. Any doubt?
No, sir.
Next, in question 4, a plane progressive wave given by y is equals to 2 times cos, you may write 6.284 as 2 pi and move this particular part inside of bracket. So you'll get 2 pi multiplied by 330 t minus 2 pi times x. So this will be your general expression. Now, coefficient of t in this part will be omega and coefficient of x will be k. We have to calculate period of wave, that is time period. So coefficient of t in this part is omega, which is 2 pi multiplied by 3t, and it is equals to 2 pi by t. So t is equals to 2 pi cancel out. So you'll get 1 by 330 seconds. So it will be time period for this particular progressive wave. Next, question number 6. We have to calculate phase difference for lambda is 60 degree, then find part difference for this part. So first convert this particular angle in radian. 60 degree multiplied by pi by 180 to convert into radian. So you'll get pi by 3. According to formula, phase difference is equals to k times delta x, or simply 2 pi by lambda times delta x. So phase difference is given as pi by 3. Just substitute it, is equals to 2 pi by lambda times delta x. So pi and pi will cancel out. So on solving, you will get delta x is equals to lambda by 6. Atif, any doubt?
No, sir.
Question number 6 and 7 is assertion based. So first statement is, when a simple pendulum is made to oscillate on the surface of moon, its time period increases. According to the formula of time period, for oscillation of simple pendulum, it will be 2 pi root under L by G, where L is also called distance of its center of mass of bob from axis of rotation, and G is net acceleration of that particular system. As we know, size of moon, both in mass as well as radius, is smaller as compared to surface of Earth, or simply Earth. So gravity is 1 by 6 of that of Earth. So as gravity decreases, time period must increases. So this first statement is correct. Next, moon is smaller as compared to Earth. So it is also correct. And due to smaller in size of moon, we can say it will have lesser gravity. Hence, the reason is correct explanation of its assertion. So it should be option E. Riba, is it clear?
Yes, sir.
Question number 7. Particle velocity depends upon time. According to the formula for wave, velocity of particle will be equals to omega A cos omega t minus of kx. So it is time dependent as well as position dependent function. Next, for propagation of wave, the medium must have property of elasticity and inertia. So these two different terms as property of medium for propagation of mechanical wave, and particle velocity depends upon time is a different term as compared to this reason. So we can say individually assertion and reason both are correct, but reason is not correct explanation for its particle velocity or dependence of particle velocity on time. So it should be option B. Both are correct, but reason is not correct explanation of assertion. So this is all about the first part of this question paper, that is section E. Next is section B, case-based study based on simple harmonic motion. So first question is, which of the following is not characteristic of simple harmonic motion? It is periodic motion, yes. Simple harmonic motion is spatial type of periodic motion in which body is always attracted or accelerated towards their mean position. So just see option D. The acceleration of particle is directed towards extreme position. So it is correct, incorrect statement related to SHM. So option D will be incorrect. Next, question number second. The equation of simple harmonic motion is, according to formula for general expression, suppose you have y is equals to a times of sine omega t. On differentiating it, you'll get velocity is equals to omega times a cos omega t. On further differentiating, acceleration will be minus of omega square a sine omega t. So you may write this acceleration as double differentiation of its displacement with respect to time is equals to minus of omega square, and this part from this one to this one is nothing but y. In this expression, we have just used in place of y as x. So you may write double differentiation of displacement with respect to time. So you may replace it by x. So option first will be correct. Next, question number third, which of the following expression does not represent SHM? So for representation of SHM, just remember something. First, the function should be periodic. For periodic function, it should be trigonometric first. Then in trigonometric, we have 6 different functions: sine, cos, tan, cosec, sec, and cot. In those 6 different trigonometric functions, only sine x and cos x will be SHM. And in that simple harmonic, or simply sine x or cos x, it should be linear power of sine x and cos x. Suppose you have sine omega t to the power n. So if n is 1, then it will be SHM. Otherwise, it will be periodic, but not SHM. Next, if you have combination of 2 SHMs, suppose sine omega t and sine omega t with some constant phase phi, then these combination or this particular superposition will be SHM only if omega of these 2 functions will be same. Then their superimposition will be SHM. If their angular velocity, or if the angular velocity of 2 SHM will be different, then it will be periodic but not SHM. So first function will be SHM since it is a combination of sine and cos having same angular velocity. Second is also SHM. Third is also SHM, but fourth is not SHM since it is combination of sine and cos square, not their linear power. So it should not be SHM. Atif, is it clear?
Yes, sir.
Question number 4, which of the following motion is not simple harmonic motion? Vertical motion of spring, suppose you have a spring mass system oscillating up and down in non-viscous medium. Let's say viscous force of air is neglected, so it will perform SHM. Second, motion of simple pendulum, it will be SHM. Motion of planet around the sun, For a particle to be in SHM, acceleration of particle must be directly proportional to displacement with negative sign. It means it should be accelerated towards their mean position always. But in case of circular motion, there is no any mean position and there is no any acceleration directed towards mean position. So this particular circular motion will never be SHM. And last part, oscillation of liquid in U-tube. Suppose you have U-shaped tube like this, in which liquid is initially filled up to this point. So if you compress along any one side, it get raised to other side, and due to this, it will start oscillating up and down, up and down. So it will perform SHM. So option third will be incorrect. Riba, any doubt?
No, sir.
Okay. So this is all about the second section of this question paper. Section C, show that acceleration of particle in SHM is directly proportional to its displacement from its mean position. We have just proved above. Why on simply differentiating this displacement 2 times, you get required relation. In question number 10, we have 3 different arrangement of spring mass system. So in first part, single block, so time period will be 2 pi root under m by k. In second part, we have 2 different spring connected in series. So k equivalent for series combination will be 1 by k1 and 1 by k2. So it will be 2 by k. So k equivalent will be k by 2. So if you substitute this value, you will get 2 pi root under m by k, and k we have k by 2. Now if you take out this particular root outside of this particular relation, you may write it as root 2 times 2 pi root under m by k. In third part, we have 2 different spring, 2 identical spring having same spring constant connected in parallel, and k equivalent for parallel combination will be k1 plus k2. Both k1 and k2 is same as k and k, so it will be just 2k. So substitute this value, you will get 2 pi root under m by k equivalent, which is 2k. Now take out this particular root 2 outside, so you'll get 1 by root 2 bracket 2 pi root of m by k. Now in these 3 different parts, we have this expression same in all 3. So if you take the ratio of these 3 different parts, that is T1 is to T2 is to T3. So for first one, you'll get nothing but 1. For second one, it will be root 2. And for third one, it will be just 1 by root 2. So in question number 10, you have to derive this part. Atif, is it clear?
Yes, sir.
Question number 11. The velocity of sound under STP condition. STP is standard temperature pressure, where temperature will be 0 degrees Celsius and pressure will be 1 atm. So you may write velocity as gamma times R, temperature to be 273 plus T degrees Celsius, divided by M root under. So at T is equals to 0, its value is 400. So first question is, how or what will be the velocity when pressure is changed to 2 atmospheric pressure without changing its temperature? So I defined you in factors affecting velocity of sound. If you'll be asked to define its dependency on pressure, just check the process. Is it isothermal or non-isothermal? If it is isothermal, then velocity will be independent of pressure. So in first part, since it is isothermal process, so on changing pressure, there will be no any effect on velocity. So velocity will remain same. So you may write it is unaffected. Atif, is it clear?
Yes.
In second part, we have to calculate velocity if temperature is increased to 819 degrees Celsius. So first, at 0 degrees Celsius, gamma R divided by M, 273 plus 0 root under is equals to 400 meter per second. On changing temperature, let's say this is V1, V2, gamma R divided by M, 273 plus 819 degrees Celsius root under. Now just divide these two expressions. On dividing, you will get 273 plus 819 divided by 273 root under is equals to V2 divided by V1. This part will cancel out in one time. This part will cancel out in 3 times. So 1 plus 3 will be 4. On taking square root, it will be 2. V2 divided by V1. V1 we have 400 and V2 we have to calculate. So it will become 800 meter per second. So this is the second part of this question. Umar, any doubt? Okay. Question number 12. Why and how Laplace corrected Newton's formula for velocity of sound? According to Newton's assumption for propagation of sound, it was isothermal process. For isothermal process, beta will be simply pressure. And if you substitute pressure and density of air, you will get about 280 meter per second, which is smaller as compared to the actual speed of sound. According to Laplace, process of sound propagation will be adiabatic, and in case of adiabatic process, beta will be equals to gamma times p. So if you substitute the value of gamma, you will get the required value of velocity of sound. Hence, Laplace corrected Newton's relation by taking an adiabatic relation. Question number 13. A simple pendulum is hung in a stationary lift and its time period is t. Suppose you have stationary lift like this, and a simple pendulum is oscillating to and fro like this. So time period of simple pendulum is 2 pi root under L by G, where L is distance of its center of mass from axis and G is net acceleration of that particular system. So we have three different parts for this one. What will happen to its time period if left in going up with some uniform velocity? In case of uniform velocity, net acceleration of system will be remains G. So there will be no change in time period. So time period will remain same. That is T is equals to 2 pi root under L by G. But in second part, suppose if lift is accelerating upward with some acceleration A. Suppose this is any system and a body is placed in it. So this particular object will be experiencing a downward force due to gravity if the system is at rest. Now suppose if the system start accelerating upward at some acceleration A. Riba, what will happen? If system start accelerating towards any direction, will there be any change in force or it will remain same mg? Atif, any idea? Take your notebook, place your pen on it, and just move your register to any one side, towards right or left, on sudden accelerating it. If you accelerate it, this pen will move just opposite to the acceleration of your register. So you will say, for accelerating of system, a force will develop into it, which is called pseudo force, and it must be acting opposite to the direction of acceleration of system due to inertia. So in this part, if lift start accelerating upward, a pseudo force will act on this particular object in opposite of it, having m into a force. Atif, is it clear? Umar, any doubt? Just 1 minute. So in this part, since lift is accelerating upward, so net force experienced by this particular block will be m times g plus a. Other than this particular mass, acceleration of this body will be g plus a. So just remember, if system is accelerating upward, net acceleration on body will be downward as g plus a. And similarly, in this part, if lift is going up, so net acceleration on this simple pendulum will be g plus a. So in second part, time period will become 2 pi root under L by g plus a. And since acceleration is increasing, so time period will decreases. So you will say time period will decreases. In this part, time period will be same. In third one, if lift comes down with uniform acceleration a. So for upward acceleration, net pseudo force will be in downward direction. So similarly, if lift is going downward, pseudo force will be in upward direction. So in that part, time period will become 2 pi root under L by G minus A. So net acceleration is decreasing, so time period will increases. Atif, is it clear? Riba, any doubt? In question 14, a mechanical wave travels along a string described by this. Y is equals to 0.005 times sine 3 into t minus 80 times x. So if you compare this expression to the actual expression of wave, you will say this is amplitude, coefficient of t is omega, and coefficient of x is k. So we have amplitude is equals to 0.005 meter, omega is equals to 3 radian per second, and angular wave number is 80 radian per meter. So this is the given part from this question. We have to calculate first amplitude of displacement, which is 0.05. So this is your first answer. Amplitude of velocity. So if you differentiate this particular expression, you will get particle velocity is equals to omega times a cos omega t minus of kx. So coefficient of that function, this one, is called amplitude of particle velocity, or it is also called maximum particle velocity. So you may write this part as amplitude of particle velocity, or simply maximum particle velocity, which is nothing but omega times a. Omega we have 3 and a is 0.005. So on solving, you will get 0.015 meter per second. Similarly, next we have to calculate wavelength. We have k, angular wave number. So according to the formula, k is equals to 2 pi by lambda. And k we have 80. So substitute this. So lambda will be equals to 2 pi by 80, that is 1 by 40. Pi by 40 meter. Next part is time period, amplitude of acceleration. So if you again differentiate this particle velocity, you will get particle acceleration as minus of omega square a sine omega t minus of kx. So coefficient of this particular function, that is from this point to this point, is called amplitude of particle acceleration. Amplitude of particle acceleration, you may call it as maximum particle acceleration. So if you substitute their value, omega square, that is 3 into 3 times a 0.005. So 3 into 3, 9, 9 to 5, 45. So it will be 0.045 meter per second squared. Next, you have to calculate time period. According to the formula, time period, or for calculation of time period, we must need omega. And omega, we have 3 radian. So omega is equals to 2 pi by capital T, or simply 2 pi into frequency nu. So T will be equals to 2 pi by omega, which is 3, or frequency is 1 by time period. So 3 by 2 omega. It will be in seconds and it will be in hertz. Any doubt in any of the solution? Okay. In section E, we had 2 questions. First is, draw a graph showing variation of kinetic energy and potential energy of particle executing in SHM with its displacement from mean position. According to the expression, potential energy is half m omega square y square. Kinetic energy is half m omega square a square minus y square. On adding these two parts, total energy will be half m omega square a square. So in this part, we have to plot its graph. This is energy versus displacement. So for potential energy, if y is 0, it will be 0. That is, at mean position, potential energy will be 0. So graph will be like this. And for kinetic energy, at mean position, kinetic energy will be maximum. So graph will be like this. So this is potential energy, this is kinetic energy, and this is total energy. So this is variation of energy with displacement. Next, show that the total energy of particle executing in SHM is conserved with time if dissipative force is neglected. So we have first potential energy, second kinetic energy. On adding, you will get this part and you will say this will be constant. Hence, total energy of particle executing simple harmonic motion will be constant if viscous force of air is neglected. Next, in question number 16, first, what do you mean by beats? So you'll say beats is nothing but when two sound waves having same amplitude, same phase, and slightly different frequency propagating along same direction superimpose over one another. So it will produce combination of loud sound and faint sound. This combination is called beats. So beats is nothing but combination of loud sound and faint sound produced by superposition of two waves having slightly different frequency, same wavelength, same amplitude, and same phase. Next, we have to define, show that number of beats produced per second is equals to difference of frequency of two waves. So you may write, let y1 is equals to a times sine omega 1 into t, or you may break this particular omega as 2 pi f. So it will be a times sine 2 pi f1 into t, and y2 is equals to a times sine 2 pi f2 into t. On adding these two segments, y will be a sine 2 pi f1 t and sine 2 pi f2 into t. If you add these two parts as sine c plus sine d is equals to 2 times sine c plus d by 2 times cos c minus d by 2. On substituting in this formula, you will get y is equals to 2 times a sine pi f1 plus f2 times cos pi f1 minus f2. So in this particular result, we have two different waves oscillating with two different frequency, one having sum of frequency of two wave and one having difference of frequency of two wave. This addition part will define you the amplitude variation, and this part will define you the loud and faint sound of that particular beat. Let me just show you. We have two different waves having different frequency, same amplitude, and same phase. It means starting from same initial point. So on superimposing these two waves, it will produce two different waves. One the outermost part and one the innermost one. So we have two different oscillating waves. The outer one define you beats, that is loud sound and faint sound combination. The inner one simply defines the variation of their amplitude. So this one is called beats frequency. Atif, any doubt?
No.
So this is all about this entire question paper. Now, if you have any more doubt related to this part, this two chapter, or any other chapter, you may ask. Riba, any question? Umar? Okay. So in next class, I will give you question paper based on thermal properties of matter, thermodynamics, and kinetic theory of gas. So just revise these two chapters. We will do test on in next class. Okay, so let's stop here for today. We'll continue next class. Okay. Okay, thank you.